So hey, thanks everybody for joining me on our second live stream that we've done regularly scheduled. What we're doing is a series of every week on Wednesday at 1 p.m. Central Time. We're doing a streaming of Leeds Helpful, Leeds Helpful Tips on some of our live streaming things, on some of our products. Today's video stream is going to be going over our motorized stages on our comparison microscopes. Last time we did diopter numbers. Please feel free to watch your videos. We hope that they're helpful, and we hope that they're also hopefully somewhat entertaining. And then also you just learn some things when you watch the videos and that type of thing. Before we jump into the microscope behind me today, just a couple of quick things. These are helpful tips that we've learned, things about our products, interesting things. If there are more topics that you are interested in covering or you would like us to go into, please feel free to email me at jkurth@leedsmicro.com, and then we can add them as topics. Additionally, what's kind of neat with doing everything through YouTube live stream is there's a chat window that if you have a Google account, you can log into, and you can type your questions there. And I think that can be a really good way, as we do the stream, if you see anything that you're interested in or want to know more about, you can absolutely just feel free to interrupt me, type it in, and then I'll address those questions as I see them. So today's video live stream is going to be going over our motorized stages, and then let's get into it. So motorized stages are kind of sometimes a hot topic for firearm examiners. And a large amount has to deal with, in our experience, about control. Being able to move the stages, see everything move. Firearms examination is a very manual process. You're moving things, you're looking at the evidence, you're rotating the bullet, looking at the cartridge cases. And that remains to this day. And Leeds, and I'll go through it in a second, but when we set out to make a motorized stage, the development started on these motorized stages right after I joined Leeds. But one of the things that we've been really careful with is still trying to keep that manual feel. The big question you may have is, why motorized stages? Why did you do that? And it comes down to a couple things. A big thing was that at that time period, we had a version of our firearm comparison microscope that we called the tool marks comparison microscope. Leeds has an agency that we've done business with over the years that had requested something a little different than our standard microscope to look at lots and lots of tool marks evidence. Yeah, so this was the LCF tool marks. And the pros are you have these very large stages. They're mechanical, you can move them around. But the disadvantage is that if you have a mechanical stage that's large like this, you need to find a place where to put those controls on that mechanical stage. And by being mechanical, you always have to have linkages or things, and that necessitates where you put those controls. So everything's compromises, and so what we ended up doing is, for our focus, for our motorized, or for our manual controls on this microscope, we ended up putting, as you can see in the picture, everything low underneath the table. And while it works, and you can see we have some armrests there, and while it works, our customers were happy with it. It's one of those things that we've always kept in the back of our head of how do we improve upon it, how do we make it more ergonomic, and just keep all the controls above the station, above the table. And that's really where the conversation started, was about the stages themselves. How do we keep everything up? So the motorized stage you see behind me, it actually started its life in designs as a manual stage. But as our designers were working on it, what they quickly discovered is you would have to put the controls in unusual places or have some very, very interesting and difficult mechanical adjustments to be able to bring the controls to a better place. And what we decided at that point was to try to investigate motors, try to investigate how we could make a motorized stage feel like a manual stage without, driving any examiners irate, and actually have it be a helpful tool. Because by switching to motors, What that allows you to do is you can now place your controllers wherever you would like. You aren't limited by where the mechanical linkages are. You can place a controller any place on the station. And that was very attractive to us, particularly when we're working with very large evidence and things that we need to be able to move around. So, like with all of Leeds products, we worked with examiners, and we spent time building stages, testing stages, getting feedback from examiners, really trying to build it. And it was fairly recently that our team had an epiphany, and we had been spending a lot of time trying to make a controller for the stages. And what we had was an epiphany. Is like, wait, people have already been doing this. People have been spending huge amounts of time trying to figure out how to make devices that connect to something that you can move around easy. And that breakthrough kind of came through when when our engineer decided to check out USB mice. One piece of feedback that really came to mind, we went through lots of iterations, lots of tweaks, asking people for feedback, and we found one particular examiner, and it was great because we had her come in, had her sit down, look at it, and she has a particularly colorful vocabulary. And so, we put it up, we put the stages, we had our original controller, which I'll show you guys in a little bit, and she said she hated it. And it's like, but she used more colorful language than that, so, but she has said she hated it, and it was like, oh man. Well, that's what you ask for if you ask for feedback. And so what we asked her to, guide us through what you didn't like. And what we discovered is it really came down, like I had said at the beginning, to control. Seeing the stage move as you move, feeling as though you do have full control of the specimen, not waiting for like a wheel to catch up to you. If you make a movement, you want to see a movement. And it's really about that precision and control. So yeah, so what we ended up doing is we really focused on that. And we came up with our designs of these holders, of these manipulators. And then the epiphany came, like I said, for pointing devices. And we ended up actually having several different types of pointing devices. So actually, what I'm going to do now is switch over to, and try to zoom in this camera, and just go over some of the features of the stage that we have. And then also just talk about our different types of controllers, because they're pretty cool, and I get excited about this kind of stuff. All right, so this is one of our controllers that we came up with. And what's neat about using a trackball is our original design, and I'll grab that and show you guys it real quick. And this is still available, I might add. Some people do prefer this design, others do prefer the trackball. But the original design that we were building was really built around our LCF3 comparison scope, and our original systems and Discovery systems. And so the idea is that it would sit here. It's magnetized on the bottom, so you can place it any place on the table. We've inserted a little magnet system in here. And then this is your x-axis, this is your y-axis, and then you've got your z for focus adjustment. But what was interesting as we were working with it is the reason the mechanical stage needs controls like that, needs discrete controls x, y, and z, is because it's mechanically moving things. And I'm sure somebody's invented a mechanical stage that can do 3 axes all at the same time, but that's what was kind of, if we figured out, or our engineer figured out, is if you're already having motorized stages that can do this type of motion, that can do multiple types of motion at the same time, why not look at some different types of controllers? And so if you look, actually, our literature, it will even show some of those early controllers that we had as options. But with this particular controller, what's cool about it is that it's a trackball. And what's nice is it's a resin, or maybe it's a heavy plastic. But what that means is that it adds, I was playing around earlier, it adds mass. And so there's inertia to it. So instead of just feeling like a small little trackball that just whizzes away as you move things around, what we have here is the ability to really you actually have inertia. So you feel weight as you're moving the stage. And that's nice because then your input-output is, for me, it just evens it out. So yeah, you can kind of see how the stage moves. What's neat about it is, for me, it feels like my hand is inside the microscope. I don't know how else to describe it. Because you're moving around, you go exactly where you want to go, and then you can let go. On this controller, we have a button on the right side, and what this does, you'll notice that everything is at least a double tap, or a double click. I think everything is double click, and we figured that out real quick when we had this trackball or any of our controllers, that you have to have a double click, otherwise you accidentally bump it, and then you're going to shift everything you're working on. So what we did is it's a double click. So on our right side, if you double click, it changes between coarse and fine motion. And I'll show you more about that in a second. So we're moving around, and it's doing a lot more finer motion. If you double click it again, it goes back to coarse mode. And this allows you, to do really big moves, as you can see. So imagine if you had a large tool mark or something on here that you were looking at, this would allow you very easily to maneuver around your sample. This side of the controller, if you double click it, what it does is it synchronizes both stages. So, and that's a cool thing that you can do with these stages, is that you can synchronize them and they're really tight. They're very, very tight. So if I double click it, I'm now synced. So now if I move both stages, it's a little more impressive if I zoom out a little bit more. You can really see how both stages are moving exactly and synchronized. Another neat thing that we do, and it's unique by being able to switch to motors and then by doing all of our own development in-house, is we can then take feedback and build it in. So one of the things that we built in recently to the controller systems is one-handed operation. We had a customer that has a disablement in one of their hands, and talking to them and working with them and just seeing how they use their comparison scope, what we decided to do is build in a one-handed operation mode. But it's the same thing here. What this is a long hold. So if you press and hold down your left button, it'll turn on one-handed mode and go to the opposite stage. So now when I do my movement, it's going for my right stage. If I hold down the button again for another 2 seconds, it switches back to that stage. Stage-wise, there's a third button. A couple more things to just show you guys. This button here is, you can kind of see it, there he is. This is a lock. So if you double-click this button, what'll end up happening is, I guess, quick note, the neat thing about a trackball is you have total control and freedom of movement in all directions. The disadvantage, though, is if you want to do just a very careful vertical measurement, like with a land or groove impression. So that's where this little lock comes in place. If you double-click this, what it will do is it'll lock it just so it's in the y-axis, the movement. So it'll ignore any x inputs and only do a y input. And that, when paired with our touch controller, and if you zero the scale, you can zero both x and you can zero y, but this will actually allow you to do very easy, don't know how well you can see that, but very easy measurements in the y-axis. Just something else to show you guys. We also have on it, obviously, you need to focus. So we actually have a little scroll wheel located here. And then this allows you to adjust your focus. So you can move it up, you can move it down, that type of thing. What's kind of neat is you have all these capabilities here, but you also have other controllers, and I'll show you another one in a moment. But you may be wondering, okay, great, Jake, you have the ability to adjust between coarse mode and then fine mode. But one of the problems that has happened with, or in general, with any control system is if it's not fine enough or if it's not coarse enough. And so what we do is we do a couple things. The first thing that we do for all of our motorized LCF and Discovery systems is we've added as an option, you can click this little gear icon. You can hit this little gear icon, and then what you can do is you can actually adjust the trim. You can adjust the fine focus or the fine adjustment, and you can also adjust the coarse adjustment. So The concept is to make it customizable for the individual examiner. So you really can, and you can too, it's very granular, so it goes up to 15 steps. And that allows you a lot of flexibility in picking just the right motion and just the right control. And this right here, this feature here, paired up with the responsiveness of these stages, I think is why a lot of examiners that we've been working with, once they play with it, once they get to use it, have really preferred our motorized stages over manual stages. And the reason is you have so much more control. I'm going to embarrass myself. I hope it's control authority. I'm going to call it control authority. You have so much control authority. It does what you want it to. If it's not, you can come in and adjust the fine. You can adjust the course and make a measurable impact. And that's really nice because then you don't end up fighting that hysteresis shuffle, especially at high magnification, where you overshoot, undershoot, overshoot, as you just work to overcome in a manual system just some of the inertia of the gears, of all that. And what's specific to the Discovery system, or the Discovery-Z system, I should say, is we have this ability, it's a check mark, I know it's small, but we call it mag to speed. And what that does is the stages are watching what the zoom is, what the magnification is of the microscope. And they're reading back and forth. And why that's very helpful is as you move through your zoom range, so right now we're at low power, and I'll come in and I'll do my motion, and I have really good motion. It moves nicely at this low power, at the course speed that I like. But then as I go up to higher and higher magnifications, what's going to happen is it's going to use those magnifications, look at the trim that the examiner has set for the course or the fine, and then do the motion that is more appropriate in that mag range. So at 32, this is what our course looks like. At 63x, this is what our course looks like. And it just keeps going at 125. It keeps getting finer and finer. We keep getting more and more fine motion, all the way up to 147 on this microscope. And this, again, this is coarse movement. This thing's barely moving. If we switch to fine, yeah, we'll have to switch over to the camera internally to show you guys that. But yeah, so that's kind of the concept of that, is that the Discovery people often ask me, what's the difference between the Discovery-Z and the LCF3-Motorized? And that's going to be the big difference. So if you have a Discovery-Z, I suggest you try playing with that mag to speed option, and that's just found in the little gear icon settings, and then you just click mag to speed. Another thing that's pretty neat is, let's say you have an older LCF3 motorized or an older LCF or older Discovery-Z system. When our service teams, and I think I'm hoping I'm not speaking out of turn for our poor service guys, but the goal here is that when our service teams come on site, we can do firmware updates in the field. So if you have a request and you don't have mag to speed, or you want the most recent, just feel free to request it, and the next time we come out to do preventative maintenance, we can work and figure out how to get that in there. All right, so moving on. So I showed you guys the blue trackball. We call this the blue glowing trackball internally. We also have another trackball that has been popular too. We're starting to see more of, more requests for. And again, it's so interesting. Personally, I've never used trackballs on a computer or anything like that. One of my colleagues, he swears by trackballs. He uses trackballs all the time. Whenever I sit down on his computer, I struggle with his mouse. But this feels very intuitive, and I've just been really impressed with what our teams have been able to put together. This is our other option. What's kind of neat about it is a wireless. There's a wired and a wireless version of it. And what's neat about that is this one's unique in that you have one more extra button. And so you have the ability to control your movement here. You have a focus adjustment ring around the middle. And then you have the ability to lock X and Y with, I believe it's these top buttons, double tap for left, or to y-axis, double tap for x-axis, and the bottom two buttons still function as normal. I might have that backwards. I don't think I do, but I might have that backwards. Something to show you guys also, with motorized stages, it's interesting because I talk a lot about being able to control the motion, being able to move to where you want to move, being able to have all that. And that's most easily shown actually on the monitor. So what I'm going to do next is we're just going to go ahead and zoom out, and I'm going to put these two cartridge cases so you can kind of see what that looks like off of the monitor itself. So bear with me while I set this up. Normally I would absolutely just share my screen, but this particular computer does not have, we're still working out the kinks of our whole streaming setup, let's just say. So I'm going to go ahead and zoom in. So what I'm doing right now, and so I don't keep crossing in front of the whole microscope system, is I'm using my one-handed operation mode. Let's bring this up here. There we go. I'm using my one-handed operation mode to switch between the right side, 1, 2, and then the left side. And so I can get these stria, or these very fine markings lined up. And this I can now show you kind of that difference between the coarse and the fine. So this is what our motion looks like as we're moving around in the coarse mode. And then if I double click again, we're going to switch over. Oh, I actually had it backwards. We were in fine mode. So this is our fine mode here, and then this is our coarse mode. So let's say, this coarse mode, it's still too coarse. It's not what I like. I don't want it like that. That's where I can come over and adjust using that trim. I'm going to just decrease our coarse speed by about 3 digits. And it updates almost in real time. So you'll see that we're a little bit finer. And what I can do now is once I get things lined up, I can double click, go back to fine mode, do some fine adjustments, get exactly where I want it, and now I can synchronize. And when I synchronize, this will just kind of show you what we're working with and how we're able to keep the thing moving, or the image moving exactly together in lockstep. And this is really nice, particularly when you pair it with, if you're working on difficult samples, even large samples, things like that, when paired with that trick of, it's a parfocal zoom, just like I did with the camera earlier. If I zoom in, focus, I need to be on a flat surface, zoom in, focus, and I'm in fine mode, so it's taking a lot of time, so I'm going to switch to coarse mode on my focus. And then when I zoom out, that image remains in focus, but I can also then move the stage around very easily and just follow stria wherever it goes, or wherever that pattern goes. You'll notice that as I've been moving the stage, in this particular example, I can adjust my focus on one side without the other side adjusting. And that's an option too that you have. So nested in that same menu where you go to the coarse speed and the fine speed trim, you also have the ability to mirror focus. And what that means is as you focus on one side, it focuses on, or I'm sorry, synchronize focus. That's back. You synchronize the focus, and then what will happen is as you focus, both sides will focus together. And so that's just something I recommend getting used to, trying out. So yeah, that's basically it. So with the Discovery-Z as well as the motorized LCF3s, the idea is that we're trying to produce a stage that is as responsive as a manual stage. You can move around, you have a lot of control, but you're not just limited to one type of controller. You can use different types of controllers. And we're continually looking for feedback and using that feedback in our systems. So yeah, if you're using your scope and you find something that you're interested in, you want to know more about, you can always please feel free to let us know. Additionally, if you've watched this and you still have more questions about, how do these motorized stages work, how do they move, can we get a demo, things like that, you can absolutely let us know. We're also always happy to schedule individual training sessions. And I think that's about it. I'm trying to think if there's anything else. Weight limits. Weight limits, I think last time I checked, was about 22 pounds per stage. which is pretty good. So you can put something really heavy on the stage, like a pipe bomb or a large component, and yet you'd still be able to have the same control authority, same motion. I wouldn't expect a performance drop. Okay, thanks for watching. We'll be doing this again next week with our next live stream tutorial, or live stream Leeds Helpful Tip. Please feel free to contact us if you have any questions.